everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent, and in this video clip I want to show you how you can use Excel 2010 to compare data with a paired t-test. Now first of all we need to have some data, and here's a little experiment. In this experiment, a drug was tested on 7 patients, and these patients had some problems sleeping through the night. So the patients were observed, and there was an average sleeping time before people got the treatment. So this is patient 1 slept 3.5 hours on average per night, patient 2 4 hours, and so on and so forth. And then so this went for a while, so we got some reliable averages here in hours, and then these patients received what is claimed to be a new drug that helps them to sleep better, and again over a period of time the averages were estimated or calculated, and this time after the patients had been treated with this new drug. So what we realize is that we have a before and an after treatment. So first of all, let's look at the at a null hypothesis, and let's formulate a hypothesis. So first of all, we need to say, in our null hypothesis, there is no difference between the means of the data other than due to sampling error. So the average sleeping time for the people before the treatment is the same as the average sleeping time after the treatment. Or in other words, the two samples come from the same population. So that's our null hypothesis. We can also formulate an alternative hypothesis, and we can say there is a significant difference between the means of the data, which is caused by other influences just than the sampling error. So in this case, we would say the drug actually has an effect because there is a difference between the sleeping times. Or we can also say the two samples do not come from the same population. So how are we going to test this? Well, we can make use of a built-in function in Excel 2010. So for that we go to the Data tab here, click on it, and on the right hand top corner we get this data analysis package. And here we can choose a t-test for paired two samples. Paired means that we have a patient here, and the same patient is then analyzed later after a certain treatment. I call this t-test the before-after t-test. And it's very important that we are aware that it is the same person that we are looking at. So that's why I've labeled them patient 1 to 7 here. Of course, we need to have the same number of observations before and after, because otherwise it wouldn't work properly. So we just press OK, and now we input our data. So here this is the variable, the first range, that is the before treatment. Here we say this is the second treatment, and we don't need to say anything about the hypothesized mean difference, because we said our null hypothesis claims that there is no difference, so that would be 0, or we don't have to put anything in. And we use the critical value, critical significance level of 0.05. This is this alpha, which is 95%. We want to be 95% sure that we make the right decision. And then we just simply choose an output where we want to have it and press OK. So what we see here is we see the two different means. So variable 1, that was before the treatment, variable 2 that was after the treatment. So we have the different means, we have different variances. We have the same number of observations. That's very good. So because we tested 7 people. And now the important thing is this row here. This gives our p-value for a two-tailed test. The p-value is the probability that these data just occur because of sampling error, and two-tailed means that when we look at the alternative hypothesis, we state there is a difference, whereas the null hypothesis says there is no difference. So two-tailed, we go for this, and we find that our p-value is 0.17 or 17%. So that means there is a 17% chance that our means are the same. So let's go back to our null hypothesis, and we say our probability is 17% or 0.17, whereas we said the critical significance level is alpha 0.05 or 5%. Now we can say if p is high, h0 can stay. Sorry for the funny accent, but it helps me to remember that if p is higher than alpha, we cannot reject the null hypothesis, but we can reject the alternative hypothesis. So in other words, we can say there is no difference between the means of the data other than due to sampling or error. And that, what this basically means is there any significant difference between before and after? And the answer is no. We have to accept our null hypothesis. There is no significant difference because this 0.17, this 17%, is higher than our alpha of 5% of the how much we were willing to make a mistake, and therefore there's no difference between before treatment and after treatment. So in a way we can say that the drug does not work. I hope you found this useful, and thank you for watching.